Hello, welcome to our lecture in organic chemistry. We've talked a lot about acetals, right? This will be our last lecture on acetals. In terms of acetals as being useful as a protecting group, right? We really want to spend a lot of time talking about protecting groups. This idea that I can take a functional group, I convert it into something else that can protect it while I do some type of reaction. And then once I'm done with the reaction in particular, I can then deprotect it. I can take that group off, right? Acetals kind of fit this category as a protecting group because we're able to easily turn a carbonyl into an acetal, and then we can easily remove that acetal, right, based on our reaction conditions. So, for instance, if we had something like some type of molecule like this, right? And if, say, I want to do reactivity of the bromine, I want to work with this one, but not work with the aldehyde at all, right? What could we do about that? Well, we could actually use the acetal as a protecting group for this, right? Because what if I want to do some type of Grignard reaction, right? If I wanted to turn this into a Grignard, it wouldn't be very compatible with each other, right? So what we can do here is I can add in NTSOH. I can make this group here, right? And so what I did is I converted the carbonyl here into this acetal, right? Now we've protected it. It's officially protected. Once we make this group here, this acetal, so the acetal is stable to base, oxidation, reduction, and nucleophilic attack. Right? So once we form the acetal, it's going to be stable to all these conditions here. I can't react it with the base, it can't be reduced or oxidized, and we can't do nucleophilic attack, right? But we have this bromine here, right? This bromine we can do a lot of chemistry on that bromine, okay? And so we can look at it in terms of it's really great for using acetals to protect against for making Grignard reagents, right? Making our Grignards. So now I can take my acetal, okay, and I can then expose it to Mg. Okay, do what? We can make our Grignard reagent. Then we make our Grignard reagent, and now what I can do, I can go ahead and add in some. Let's add in some type of carbonyl here, right? We can add in some type of carbonyl. That's the first step. Second step is going to be addition of water. And we already talked already about how this can work, right? How we can take our Grignard reaction, it can react with our carbonyl, shown here. Again, with another aldehyde. Again, if we didn't have this acetal, if we didn't have the acetal here, this was just the aldehyde, you can imagine all the extra reactivity we have, right? This wouldn't be very stable to having a Grignard on one side of it, right? So by protecting it, we basically made this whole functional group inert. It's not going to be reactive at all. So now all the reactivity will happen on this bromine side, the side we're interested in, okay? Protecting groups are great in organic synthesis because they help us isolate it so that we isolate and only work with one function group at a time, not work with multiple function groups. So by doing this, we can add this group on there, and so we're going to get that's over there. Get OH here. So we get this group here, right? We get addition of our carbonyl against with that Grignard reagent, right? And so once we form this group here, what's going to be our last step? How can we deprotect it? And as we talked about in our last lecture as well, all we need to do is throw it under acidic conditions with a lot of water, right? Water conditions. So now I can add an H3O plus. Again, remember H3O plus means it's acid with a lot of water in there, a lot of water. And now we can remove that group selectively and we get to what? Now look what we did. And now we have both our alcohol to work with, and we also have that carbonyl to work with, right? And we can do some other chemistry with that, right? And say I wanted to say, I don't know, I don't like this alcohol being here. I want to convert it into a carbonyl. I can do what? I can do PCC. Right? Now I have two carbonyls in there, right? Started with. And notice, again, we started with this reagent here, that aldehyde and a bromine. If I didn't protect it, I wouldn't be able to do this chemistry here because this would be very reactive, okay? Very reactive to that granular reagent that we create. But by making this acetal, we made a protecting group, right? Our protecting group is going to be stable to all these types of conditions so that we can do all these types of reactions available to us, right? As we move forward on, we're going to see a lot more functional groups, right? We're going to have molecules that have multiple functional groups in them. So we have to be kind of mindful about the reactivity of these different functional groups, right? And protecting groups will start being a little bit more useful for us, right? Be very important for us, all right? So that's our lecture on acetal protecting groups. And you can use these groups for lots of different types of reactions and things. And when we move forward, particularly with synthesis, we'll use them more often.